Hello students and welcome to today's video session. I am Randeep Singh and today I am going to teach you first chapter of class +1 physics, that is physics and natural phenomena. So before starting the chapter, question came to our mind that what is physics? Why we are studying physics? What is the importance of physics? What is the scope of physics? So all these questions are answered in that chapter. And the word physics came from a Greek word that means nature. So physics is basically related with the nature and the natural phenomena. Study of physics is related with the nature and natural phenomena, and its Sanskrit equivalent word is bhautiki, that is used to refer the study of physical world. So there is no precise definition of physics, and that's not needed at the moment. But we can broadly describe the physics as a study of the basic laws of nature and their manifestation in different natural phenomena. So basically physics is related with nature and the natural phenomena. So students, in this chapter you will get to know how we can relate physics with various physical phenomena. Also you will learn about some great physicists and their contribution to the field of physics. So this chapter is basically designed to motivate you people because you have chosen to study physics, and believe me, it's a very interesting subject. You will love physics. So it's my request all of you to study this chapter thoroughly. Although you may not be able to understand or grasp some important concepts at the moment, you can also search from the internet about some great physicists and take an inspiration from their work. So students, now we are studying our first topic, that is force. So in the previous classes all of you have studied about force, that what is force. Force is a push or pull. Force is needed to hold the objects, to carry the objects, and to deform the objects or to break the objects. So all of you have the basic idea about the force, but we don't know how many different type of forces can be in the entire world. There are several types of forces in the entire world. So we can broadly classify the different type of forces into four categories. There are four basic fundamental forces in nature. So first one force is gravitational force, the force of attraction between any two objects that has mass, that is called gravitational force. All of you have studied in class 10th and 9th about gravitational force. And gravitational force is a universal force. So gravitational force is present everywhere on the earth and in space. But remember, its strength is very weak for material objects, and also it doesn't need any intervening medium because it is present everywhere. That's why it is called universal law. And remember classic example of falling of apple on the ground, when Sir Isaac Newton gave idea about universal law of gravitation, that is F is directly proportional to the mass of two bodies and inversely proportional to the square of distance between them. So all of you know about universal law of gravitation. The distance up to which gravitational force can act is infinite, that is its range is infinite. And also it doesn't need any intervening medium. It don't need any medium. It can act in space also. But remember one thing, the strength of gravitational field for material object is very less, because the mass of material object is very less as compared to the mass of earth. That's why its strength is less, because if mass of two bodies will be less, then force of attraction will also be less. But gravitational force basically governs the motion of the celestial bodies, like motion of the earth around the sun, motion of the moon, and other artificial satellites around the earth. So that's all about gravitational force. Now proceeding to our next type of fundamental force, that is electromagnetic force. So this force is between charged particles, between two positively charged particles and two negatively charged particles. As you all know, like charges repel each other and unlike charges attract each other. Remember that you have also studied in class 10th Coulomb's law of electromagnetic induction. The force between charged particle is known as electromagnetic force. So the word electromagnetic coincides two terms, that is electro and magnetic. Why two terms in a single word? Because charges in motion has magnetic field around it. As you have studied in class 10th, that whenever current flows in a circuit, it produces a magnetic field around the circuit, and also we can produce the current in the circuit by changing the magnetic flux linked with the circuit. Now, like gravitational force, electromagnetic force can also act up to infinite distance, that is, its range is infinite and it does not need any intervening medium. But remember one thing, that it is much stronger than the gravitational force. The strength of electromagnetic force is much larger than the gravitational force. Alright, till now we have studied about two forces, that is gravitational and electromagnetic force. Now we all know that like charges repel each other, but they do have mass. Protons, like two positive charges like two protons, has mass and they repel each other. But the mass of proton and electron is very less. For example, mass of proton is 1.672 into 10 raised to power 27 kg and mass of electron is 9.1 into 10 raised to power minus 31 kg. And due to their less mass, the gravitational force between them is very less as compared to the electromagnetic induction. That's why like charges repel each other, because that electromagnetic force is much larger than the gravitational force of attraction between them. Got it? Now you have clearly understood that electromagnetic forces overcome the gravitational force for minute particles. Now moving further to our next type, that is nuclear forces. The nuclear forces are the forces that binds protons and neutrons in a nucleus. As you have studied in your lower classes, that in the nucleus of an atom, protons and neutrons are present and electrons revolve around the nucleus. But as we all know that protons has the same charge and they should repel each other. And how it is possible for the protons to reside in the nucleus? Because the nucleus should be unstable due to the fact that they has the same positive charge. But as we all know that nucleus is completely stable, and it is only possible because of the presence of strong nuclear forces that binds the protons and neutrons all together. The strong nuclear forces binds protons and neutrons in the nucleus. Here's the property of nuclear forces. They are the strongest forces in nature. They are the strongest forces and they are charge independent. What it means? It means that nuclear force between proton and proton, neutron and neutron, and as well as neutron and proton is same. The strength of nuclear force do not depend upon the charge. Is that clear? And the range of nuclear forces is extremely small. It is of the order of 10 raised to power minus 15. And that's why electrons do not feel any nuclear forces. And remember, electrons are held in the atom due to the electromagnetic forces, electromagnetic interaction, electromagnetic attraction between positive nucleus and electrons, because electrons has a negative charge. Moving to our last type, that is weak forces. That appears only in certain nuclear processes such as beta decay of a nuclei. So students, you will learn in detail about beta decay of nuclei in class 12, so don't worry. And the range of weak forces is extremely small. It is of the order of 10 raised to power minus 16 meter. And the strength, they are weaker than the nuclear forces but stronger than the gravitational force. And here's the table for relative strength of all the forces. If we suppose the strength of nuclear forces as 1, as we all know, nuclear forces are the strongest forces in nature, and the second strongest forces are electromagnetic forces. Their relative strength as compared to nuclear forces is 10 raised to power minus 2, and the weak nuclear forces, their strength relative to nuclear forces is 10 raised to power minus 16, and the last weakest forces are gravitational forces, and their relative strength as compared to nuclear forces is 10 raised to power minus 39. So that's all about 4 fundamental forces in nature. Now an interesting thing is that the unification of theories. The work is going on to unify all these four theories into a single theory. Until now, electromagnetic forces and weak forces are combined and they are called electroweak forces. We have the theory for electroweak forces, and the work is still going to coinciding this theory with the nuclear force as well as a gravitational force, so that we can have only a single theory. Okay, that's all for today's video session. I hope all of you have understood well. Thanks. Have a nice day.